Hi everyone, welcome back to Life Technologies channel, and thank you for watching and supporting our channel. So today we are continuing with our Huawei Lab simulation series, and in today's episode our focus will be to demonstrate how to configure or how to implement OSPF version 3 on Huawei routing devices. So we know many service provider and many enterprise networks are migrating from IPv4 addressing to IPv6 addressing, or they are running both IPv4 and IPv6 on their networks. So it's a basic requirement for an IP engineer or a network engineer to understand how to configure IPv6 addressing on the network and the basic operations. So if you are running IPv4, we know you can deploy OSPF version 2 that purely supports IPv4 addressing. But in case you have IPv6 addressing, then you need to deploy OSPF version 3 that supports IPv6 addressing. Both OSPF version 2 and OSPF version 3 have many similarities with just little differences. So in this episode, our focus will be how to enable IPv6 addressing and how to configure IPv6 addresses on Huawei routers. And then the next step will be how to configure OSPF version 3 on Huawei routing devices. So as you can see, this is the topology, and we have three areas. We have area 0, which is connected to area 1 and area 2, and we have 4 routers, R1, R2, R3, and R4. The IPv6 addresses are assigned as shown in the topology on all the interconnected links between different routers. So the first step of our configuration will be the basic configuration, basic interface configurations. And in this step, we are just enabling IPv6 on the router and configuring IPv6 on the interfaces. So on Huawei routing platforms, before you can assign IPv6 addresses, you need to globally enable IPv6 on the router or the switch. So you need to run the command IPv6, and once you've run the command IPv6, you also need to enable IPv6 on the specific interfaces. So that's why we are having to run the command IPv6 enable on the interface before we can now assign IPv6 addresses. If we can just demonstrate, if I log into R1 and display current configuration, interface gig 0/0/0, you can see we don't have an IPv6 address. If I go under this interface and I try to assign an IPv6 address, just copy this command. You can see that it's the command, the error is unrecognized command. This is because we have not enabled IPv6 on the global. Even if I try to run IPv6 enable, this one tells us that please enable IPv6 function in the system view. So we first need to enable IPv6 in the global, and then we can now start configuring IPv6 configurations under the interface. So these are the configuration that we are using for the basic configuration. The first step is you need to enable IPv6. Once you've enabled IPv6, you need to enable IPv6 on the interface, and then you can assign IPv6 using the IPv6 address command. Then you specify the address that you are assigning on the interface. On router 2, it's the same. You enable IPv6, then you need to enable it on the interface and assign the IPv6 addresses. Same to router 3 and router 4. So we will run these commands on R1 just to configure it. R1 system view, we are already in system view, so I'll paste these commands. So now if I go under gig 00 and display these, you can see that we now have IPv6 enabled and we have IPv6 address assigned on the interface. So we'll do similar configurations on R2, R3, and R4. So on R2, I paste. So we have assigned enable IPv6 and assign IPv6 addresses on the two interfaces. We do the same for R3. So we've done the configuration for IPv6 on R3. Then we finish on R4. So we've done the configuration. I can display this. See, we have IPv6 enabled. So once we have the IPv6 enabled, we can display IPv6 interface. So we can see that this interface has this IP configured. IPv6 is enabled and the IPv6 protocol current state is up. So on R2 we expect the same. If I do display IPv6 interface, you can see we have two interfaces that we have enabled IPv6 addressing, and even the link local address is already assigned on these interfaces because we've already enabled IPv6 globally and also on the interface. So after configuring the basic IPv6 addressing on the interfaces, we now move to the second step where we need to do OSPF configurations. So remember, we are configuring OSPF version 3. So you need to specify the command OSPF version 3 and then the process number. And then it's a good practice to configure the router ID so that it's easy to identify which router is establishing the adjacent with each other. So these are the OSPF version 3 configurations. Remember, this lab just demonstrates basic OSPF version 3 configurations, but later we can dive deeper into the advanced implementation of OSPF version 3 features. So once you've configured OSPF version 3, the second step is to enable OSPF version 3 on the interfaces. So you run OSPF version 3. This is the process that we have configured. Then we are specifying the area. So router 1 is in area 1, so we specify area 1. For router 2, we have one leg in area 1, another leg in area 0. So similar configuration on R2, R3, and R4. So we'll start by doing configuration on R1. I have the windows open. I'll go to R1. And then I do paste, have enable OSPF version 3 and enable it on the interface. Similar configuration on R2. So we have R2, we configure OSPF and enable it on the interface. Then we have on R3, then finally we have configurations on R4. So we've configured OSPF version 3 on all the routers. If I do display OSPF version 3 and you use the question mark, you can see that you can see the area, the interfaces, the peer. So if I run, need peer, not path. So if you display OSPF version 3 peer, you can see that we have one peer on R1, and this peer is 2.2.2, which is router 2. The state is full, and this is the DR. Then on R2, we can do the same, display OSPF version 3 peer. So we have two areas. In area 0, we have one peering, which is 3.3.3. Then in area 1, we also have one peer. Remember, you can do the verbose and it will give you more details, the DR priority, the dead timers, the neighbor is up for how long. This one is 38 seconds. Then neighbor events and many other details that you can view when you do the verbose command. We can also do the interface to check which interfaces have OSPF enabled. We have gig 00 is up, line protocol is up. Then you can view the details. OSPF version 3 process 10 is running, the area is 0. The network type is broadcast. OSPF version 3 also supports different network types, same as OSPF version 2, the broadcast, the point-to-point. So on our network, given that we haven't configured point-to-point, the default one will be the broadcast. Then it's also showing you the cost and the priority and the timers. So we can display OSPF version 3 LSDB and it will tell you all the LSA that you are having from different areas. You have the link LSA, router LSA, network LSA, inter-area prefix LSA. So these are just different LSA that we are having for OSPF version 3. So on R3 we can do the same, display OSPF version 3 peer. We have two peer, one in area 0 and another one in area 2. So this is how simple it is to configure IPv6 and OSPF version 3 on Huawei routers. Remember, you first have to enable IPv6 globally, and then you also need to enable it on the interface. Once you've done the two steps, you can now assign IPv6 addressing on individual interfaces. Then the last step will be to configure OSPF version 3. So guys, I hope you've enjoyed this session. If you have any questions, remember to leave it in the comment section. And thank you for watching again, and please remember to subscribe to our channel for more upcoming videos. Thank you.